solve this quadratic equation by using the quadratic formula. So, first of all, what is the standard form of a quadratic equation? What does it look like? The standard form. Ax squared plus bx plus c equals 0. That's your standard form. So before you use the quadratic formula, it's got to be in this form. And in the quadratic formula, that sheet that you had, you've got to plug in numbers for a, b, and c. So the next thing is to denote what a, b, and c are. So in this case, is this in standard form? No. So let's first of all put it in standard form. So remember, this is standard form. So I'm going to have to write this as 6x squared minus x, and then what? Minus 12 equals 0. Okay, so what's a in this case? 6. What's b? Negative 1. And what's c? Negative 12. All right, so those are the values of those letters. So remember, a is the coefficient of x squared, b is the coefficient of x, which in this case is negative 1, and c is your constant, which is negative 12. So remember, the formula is x equal the opposite of b plus or minus the square root of b squared minus 4ac. All that's being divided by 2a. And then you just plug and then you chug. So this says I take the opposite of b, right? That's what this says. So if b is a negative 1, what does this term become? Positive 1. Plus or minus the square root of. And remember, we're going to learn today that this is called the discriminant, that b squared minus 4ac. But for right now, we just called it a radicand. Remember, the radicand is the part that's under the radical. And we put all those letters in parentheses, the values in parentheses. So that's negative 1 squared. Because if you didn't put that in parentheses and use your calculator would have given you a negative 1. But whenever you square a number, not 0, but whenever you square another type of number that's not 0, this is always what kind of number? Positive or negative? Positive. So if you get this to be negative, you did something wrong, because you're squaring b. Whenever you square a number, it's always a positive number, unless it's 0. 0 squared 0. Minus 4 times a, what's a?
6.
And then times c, and what's c?
Negative 12.
All that. And remember, we talked about how to write this line right here. Let's go from here all the way across. 2 times a, and what's a? 6. All right, now we're going to simplify the radicand, the discriminant. So I get 1 plus or minus the square root of, what's negative 1 times itself? All right, what's a negative 4 times 6 times a negative 12? Use your calculator.
288.
288?
Negative 288.
No.
Positive.
A positive. A negative times a positive times a negative is a positive. All over 12, right? Okay, now 1 plus 288 is 289 over 12. All right, now that's the large number. The next thing you need to do is ask yourself, and we talked about this last time, are these going to be rational or irrational solutions? They're not going to be imaginary, because you don't see what the type of number under the square root. Negative. Although you will have that on your test. But in this particular case, they're not going to be imaginary. But you need to determine if they're going to be rational or irrational. What's the next thing you might want to do to determine that? Well, it would be rational if 289 is what kind of number? A perfect square. All right, so all you do is take the square root of 289 and see if you get a whole number or a decimal. So when I do the square root of 289 on the calculator, I get 17. It's not a decimal. It's 17. So that means that 289 was a perfect square. So that means that the square root of 289 is exactly 17. So if I were to go further, what kind of solutions would I end up with? Rational, irrational? Rational. All right, now remember, we talked about this. Since it's going to be rational, you need to split it apart like this. So you're going to say, so remember, these are rational solutions. So then you need to say 1 plus 17 all over 12. And then what's the other one? 1 minus 17 all over 12. And so over here, that's going to be what? 18 over 12, which reduced is 9 over...
3 over 2.
Yeah, if it would be 9 over 6, which reduced further is 3 over 2, right?
Yeah.
Okay. So that's one of your solutions, 3/2. The other one would be, what's 1 minus 17? Negative 16 over 12, which reduced is, they're both divisible by 4, so negative 4/3? Okay. All right, so that was that one. So that's this. Now let's do, I'm going to make up this one, so hopefully it's going to be irrational. So we're going to do one more, and then we're going to look at completing the square. All right, number 2. All right, suppose number 2, you had let's say 5x squared equal 6x minus 1. 5x squared equals 6x minus 1. All right, now again, don't make the mistake in going right away and saying what A, B, and C are, because you're probably going to make a mistake. If you do, you're probably going to say B is 6 and C is negative 1. Is that true?
No.
No. You got to first of all write this in standard form. So 5x squared minus 6x, and then what? Plus 1 equals 0. Now what's A? 5. B is negative 6, and C is positive 1, right? Okay. So then we get x equal the opposite of b. Remember, your quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. So what's the opposite of b? 6 plus or minus the square root of. All right, put all this and put in parentheses. So b is a negative 6. It's got to be squared. Minus 4 times a, which is 5, times c, which is 1, all over 2 times a, which is 5. So I get equals 6 plus or minus the square root of 36 minus 20, right? All right. So that didn't work out to what I wanted, because what are you going to notice? It'll be rational, irrational. It'll be rational again. Yes.
Can't you factor that?
What do you mean factor?
The equation.
Yeah, but I didn't ask you to factor. That's a good point, though. Because in your test, you are going to have to factor. So his question is this. Can you factor this? Yeah. Yeah, you can, but that's when the directions. I told you to do this by doing what? Quadratic formula. All right, so make sure you follow directions. Okay, so if it's factorable and it says quadratic formula, you still got to use what? Quadratic formula. All right, so that's 6 plus or minus the square root of 16 over 10, and the square root of 16 is exactly 4. All right, so that's going to become 6 plus 4 divided by 10, and then what's the other one? 6 minus 4 divided by 10, so that's 10 divided by 10, which is 1. And then 2 divided by 10, which is 1/5. In fact, you're going to learn today, when we talk about the discriminant tray, that you can tell right away if it's factorable or not by looking at the discriminant. Since the discriminant's a perfect square, it's factorable. So whenever the discriminant, the radicand, is a perfect square, it's factorable. If it's not a perfect square, then you can't factor it. All right. Now let's suppose that we end up with this. So whatever my problem is, I don't know what it is, but let's suppose whatever it was, I end up with this. I don't want to make one up because I may end up with a rational solution again. But let's suppose I end up with this. I'm making this up now. Let's suppose I said negative 3 plus or minus the square root of, let's say, 18 divided by 6. Okay? All right, so you did all that work and you got this. Now, is this rational or irrational? Huh? It's irrational because 18 is not a perfect square. In fact, if you put square root of 18 in your calculator, Square root of 18, oops, I got syntax error. Let me do it again. Square root of 18, you get this. That's not a whole number. So that means that the square root of 18 is an irrational number. There's no way you can write it as a rational number. Now remember, we talked about what rational numbers are. So these right here are rational numbers. Because remember, rational numbers are numbers you can write as a fraction where you have an integer divided by an integer. Is 1 that I'm pointing to right here an integer?
Yeah.
Is 5 an integer? Yeah, so that's a rational number. This I can write as 1 over 1, right? 2 over 2, 3 over 3, 4 over 4, negative 5 over negative 5. But those are all integers. When I went to the other one, is 3 an integer? Yes. Is negative 4 an integer? Is 3 an integer? Is 2 an integer? Yes. So all those are rational numbers. So if you're taking a square root and the radicand's not a perfect square, you're going to get an irrational number, meaning that there's no way you'll ever be able to write it as a fraction, where you have an integer over an integer. But we talked about this. So remember in your test Saturday, what you had to do with something like this, what does it got to do? You have to simplify the square root of 18. Okay? So what perfect square goes in 18? 9. Okay, good. So you're going to say negative 3 plus the square root of 9 times 2 over 6. And you could have gone off to the side and done that part. So you could have gone off here and say, well, that's the square root of 9 times 2. And the square root of 9 is what? 3. So that's 3 square root of 2, right? Okay, so that's what this is, right? So then you would say, well, that's going to be negative 3 plus or minus 3 square root of 2 over 6. And if you get to that point, all this work, you get to that point, and you leave it like that, you'll get most of your points. You're not going to get all of it because I expect you to remember some things. What's one of the things I expect you to remember with this part right here? You can reduce. Those things I have circled, they're all divisible by what? 3. They're all divisible by 3. And in fact, what you could have done to kind of save yourself is just to break it down to 2 fractions. And you would have seen that. Look, negative 3 divided by 6 plus or minus what? 3 square root of 2 divided by 6, and then reduce. What's negative 3 6? Negative 1/2. Plus or minus, and then that's 1 and that's 2, right? So that's square root of 2 over 2. Now over here, you would have just said, since they're all divisible by 2, you would have said right here, it was said 6 divided by 3 is 2. I said 2, I meant 3. So it's all divisible by 3. Negative 3 divided by 3 is negative 1, and then 3 divided by 3 is 1. So that's what you see here, 1. So there are many ways you can write this. So other ways to write the answer, remember, is just to say right here, negative 1 plus or minus the square root of 2 over 2. All these are correct. On my math lab, and there are some of you that and you know you got your first final grade on my math lab today. I mean last night. Yeah, because 1.1 was due yesterday.
Oh, yeah.
Okay. So that's the other way. On my math lab, you would have said something like negative 1 plus the square root of 2 over 2, comma, negative 1 minus the square root of 2 over 2. Or you could break it down into 2 fractions. There again, the different ways of writing this. Oops, sorry. All right, so multiple ways of writing this. But if you got up to this point right here, and this was 10 points, you probably get maybe 8 out of 10, and then you go a little bit further, 9 out of 10, and so on. Okay? Yes?
So you basically break it up into two multiplication, like if it's irrational, the square, if it's irrational, we basically break it up each time for irrational.
Yeah, if it's rational, I expect you to go and tell me what those rational solutions are.
I mean irrational.
If it's irrational, then the best you can do is do something like these 4 things. Okay?
Wait,
Okay.
So what if it comes out to like, let's say the number was 14 and it came out to 2 times 7 when you break it up?
Well, 14, there's no perfect square that goes into 14. His question says, suppose you had negative 3 plus or minus the square root of 14 over 6. Okay? You go off to the side and you ask yourself, can I simplify the square root of 14? Yes or no? No. There is no perfect square other than one that goes into 14. So you're done. That's your answer. Okay? All right, any questions? All right, so those are things you could see. So those are questions you'd be asking yourself. If you can simplify, you simplify. If you can't simplify, then you're done. Okay?
And it's necessary to break it up each time, like for the plus and the minus, you have to like. for the
You can
plus,
leave it like
break
this, or you can break it down, just like I showed you. It does not matter which one you write it as. Okay? Does not matter. Okay. Okay, now let's talk about completing the square. Now, completing the square is going to be important because we're going to need it with circles. We're going to start talking about circles as well. And there's one part of circles where you need completing the square.